Okay, today we're going to go through a few examples of naming some different molecules, okay, different types of molecules. Alright, so we're going to look at everything we've covered. Okay, so everything in the last two videos, we're just going to go through some more examples of that today. Alright, so let's start off with this molecule here. Okay, so this is our first molecule here. Alright, so what actually is this? First off, we need to identify the class of molecule here. So is it a alkane, alkene, alcohol, ester? So the way we can differentiate between them, we're going to look at a functional group. Alright, so you can see here that we have this OH. So I'm just going to, this group here, okay, that there's a functional group, and that OH group signifies that this molecule is an alcohol. Alright, that is a functional group for an alcohol. So I'm going to write that here. I'm going to write alcohol. Alright? Now, what does that tell us about the suffix? That tells us the suffix has to end in ol, or anol. Okay, so first off, to start the name, how many carbons do we have in the chain? Alright, we've got 1, 2, 3, 4 carbons in that chain. So the start of the word, the prefix, is going to be bute. So it's going to be bute. Okay. Now, this one's a little bit different because you have to actually indicate the position of this OH group, of the hydroxy group. Okay. Now, we're going to number these carbons here. So I'm going to call this one here carbon 1. Alright. Carbon 2, 3, and 4. Alright. So the way we indicate the position of the hydroxy group, we have to say this is butene 2-ol. Alright, butene 2-ol, because it's on that second carbon here. Alright, so the suffix is actually not just going to be anol, it's going to be 2-ol. So butene, so I'll write that here, butene 2-ol. Alright, and that's how you write it there, butene 2-ol. Now, the reason it's butene 2-ol and not butene 3-ol, because we could number the carbons like this. Here we could go carbon 1, carbon 2, carbon 3, carbon 4. Alright, but we want that number to be as small as possible. So we want it to be butene 2-ol as opposed to butene 3-ol. Okay? So the smaller number is what we want when we're naming these organic compounds. Okay? So this one here, butene 2-ol. Let's have a look at another example now. Okay, so this one here looks a little bit different, okay, because we have this substituent group here. And what is this substituent group? Well, that is this part here, right? So this here is called a substituent, okay? And all that means this is kind of another branch coming off the main carbon chain here, all right? And this substituent here is actually called a methyl group, okay? So it's a methyl group. Now meth, because it's 1, okay, if we had two of these groups here going up this way, and that will be an ethyl group, we had 3, propyl, and so on, okay? So in terms of naming these ones, we're going to actually do the same process. So we're going to find the longest carbon chain. Longest carbon chain here is 1, 2, 3, 4. Or, depending how you look at it, you can also go 1, 2, 3, 4. Alright, either way, we're going to have the same name for this molecule. So I'm going to say the longest carbon chain is 1, 2, 3, 4. Okay, and name it that way. So the longest chain is 4, so we know the start of the word is going to be, or the prefix of the carbon chain is going to be bute. So I'm going to write bute. Okay. But we also have this methyl group here. So we know it's butane because it's an alkane, right? We don't have any triple or double bonds or any special functional groups. Okay, it's just carbons bonded to hydrogens, therefore it's an alkane. Now, we have to indicate the position of this methyl group. So as I said before, this methyl group is actually on the second carbon. Alright, now the reason for that is because we have 1, 2, 3, 4. Okay, we can see there that that branch is coming off the second carbon. Okay, or we can also look at it a little bit differently, like this too. So, okay, so depending how you look at it, you can actually say that this one here, this group, is also the methyl group. So it just depends on how you look at the molecule and how you name those carbons. So what we've done there, I've done first carbon, second carbon, third and fourth, but either way, the name is still going to be the same, because that methyl group is off this second carbon. Okay, so because of that, the name is going to be 2-methyl butane. Alright, so 2-methyl butane. Okay, so that is the name of this molecule here. Okay, and that's called a substituent. And we have a methyl group coming off the carbon either here or here. Okay, that's called a substituent. Alright, let's have a look at another example now. Alright, let's have a look at this molecule here now. What is this molecule? Well, we can see that it's that funny one where we have a alcohol and a carboxylic acid kind of coming together and forming one molecule, right? So the process in which these two molecules come together is called esterification, and they form an ester. So what we have here is an ester. It comes from a carboxylic acid and an alcohol combining together. Alright, so this is an ester. We have the carboxylic acid here, and we have the alcohol here. Alright, so that's the carboxylic acid, and that there is the alcohol. Alright, so the naming for these ones, the first part of the word comes from the alcohol. Okay, so which one of these would be the alcohol? We know that alcohols don't have double bonds to oxygens, right? Then they have single bonds with an OH group. So this one here only has single bonds, and it has a single bond to its oxygen here. So this part is the alcohol, and the part with a double bond to the oxygen comes from the acid. Okay, so the first part of the word is the alcohol, and that's going to be pro, because we have 3 carbons. That's going to be propyl. Okay, propyl. And now the acid that it came from is methanoic acid, right? We only have 1 carbon, so it came from methanoic acid. So the name of this molecule is propyl methanolate. Okay, methanolate. Okay, so propyl, that is from the alcohol. Okay, from this part here. Okay, methanolate comes from the acid, alright, and that is from this part here. Okay, this section here is the acid, right, and this here is the alcohol. Alright, so that's the name for this molecule here, propyl methanolate. Okay, and that is an ester. Now let's have a look at another example. Okay, so what do we have here? Well, we have to start off by looking for any functional groups or any giveaways that might tell us more about this molecule. So what's different about this molecule when we compare it to an alkane? Well, we have a double bond here, right? So a double bond between these 2 carbons, and there's no other real atoms here. So it is just hydrogen and carbon in the presence of that double bond. And what does that tell us? Well, it tells us that this molecule here is an alkene. Right, remember alkene is when we have a double bond between 2 carbon atoms. Alright, so this is an example of an alkene, so I'm just going to circle this part here. An alkene is where we have a double bond and there's only hydrogen and carbon bonding occurring. Alright, so that's a alkene. Okay, so now, once we've established it as an alkene, we need to determine, first off, how many carbons in that chain. So we've got 1, 2, 3 carbons in the carbon chain. That tells us at the start of the word is going to be pro. Alright, so it's going to be pro. And remember the suffix for alkenes is "-ene". Alright, so this part here, that is a suffix. I'm just going to move that. I'm going to put it up here and it becomes propene. Alright, now that is the final name for this molecule here. Now, usually we would have to indicate the position of this double bond, okay? But even if this double bond moved over here, we would still have the same name. Because if we number these carbons down, so we've got carbon 1, carbon 2, carbon 3, right? So we could write 1 propene, okay, because it's in the first carbon. Now if we labelled it the other way, so if we made this carbon 1, this carbon 2, and this carbon 3, that wouldn't actually be correct, because we want the number out the front to be as small as possible. So 1 propene is more correct than writing 2 propene, alright? Because if we switch these numbers around, this is the incorrect way of doing it. So if we did 1, 2, 3 like that, and we said 2 propene, that is incorrect, okay? Because we want this number here to be as small as possible. So that is why it is 1 propene and not 2 propene. Okay, so 1, 2, 3. Okay, so that's an example of an alkene. Let's have a look at another example now. Okay, so we've got 2 different molecules here. Alright, they're very similar. The only difference between them is one of them has a double bond to oxygen, okay, down the bottom here, and the one above doesn't have that, okay? So that's the difference between 2 very similar classes of organic molecules. Okay, so the functional groups here, although similar, are very different and have different names. Okay, so the functional group here is the double bond to oxygen, and also this NH2 group here. Now, this bottom one here, that functional group is a amide functional group. Okay, so this bottom one here, the example of an amide, and the one on the top here, that doesn't have that double bond to oxygen, is an example of an amine. Okay, so amine just has an NH2 group, amide has a double bond to the oxygen there. Okay, so let's write down the names for these molecules now. They both have 2 carbons in the carbon chain, so they're both going to start with eth. Okay, we have eth and we have eth. The part that changes is the suffix, because one's an amine, one's an amide. So the top one, the suffix for amines is ethanamine. So just an amine is a suffix for amines. Okay. Suffix for amides is ethanamide. Sorry, just an amide. So ethanamide. Alright, that is the name for the molecule down the bottom here. Okay, so we can see very similar, and the reason I wrote them like this, one on top of the other, is to show that there is a very subtle difference between the 2, and it's something that people often get confused with in practice questions and in exam questions. Okay, so amide has a double bond to oxygen, amine just has that NH2 group on the end. Okay, cool. Now let's have a look at one more, a little bit more tricky. We'll have a look at one more harder example. Okay, so first look at this molecule. There's a lot going on here. Let's break it down into what we can see. So we can see that there's a OH group here. We also have a CH3 group coming off of this carbon here. Alright, now in terms of what functional groups are present, so the substituent, remember that little branch is coming off, so this here is a substituent, that actually isn't a functional group. So when we name it, we don't name it, the suffix is not dependent on this little branch here. So the type of molecule that this is actually an alcohol, because we have that OH group here. So that OH group makes this molecule here an alcohol, but we just don't know what type just yet. So we know it's an alcohol. One of the first things you should also do is find the longest carbon chain. Okay, so let's have a look. So we've got 1, 2, 3, 4, 5, 6 carbons in this bottom chain here. Now if we count this way, we've got 1, 2, 3, 4, 5, and then we've got 1, 2, 3, 4. So the longest carbon chain is going from this carbon here, going to this carbon. So I'm going to go ahead and label those carbons now. Okay, so I've now labelled those carbons 1 to 6, so we know where to indicate the position of the hydroxy and also this methyl group here. So let's start with the prefix. So we have 6 carbons in the carbon chain. So we have 6, so we know at the start of the word is going to be hex, right? Hex is the prefix for 6 carbons. So we have hex. Alright. And we know that we have an alcohol. We have to indicate the position of that alcohol. Alright? So this OH group here could be on any one of these carbons. We have to say which carbon that hydroxy group's on in the name. Okay? So this one is actually going to be hexane 3-ol. Alright? So hexane 3-ol. Okay, because that alcohol group is on the 3rd carbon. Okay, we also have to say the position of this methyl group here. Alright, so this group here, that there is on the 4th carbon. Okay, so this is a methyl group on the 4th carbon. So we write 4-methyl. 4-methyl. Hexane 3-ol. Okay, let me rewrite that a bit bigger down the bottom here. Okay, so we have 4-methyl hexane 3-ol. Alright, this is a more tricky one, but as soon as we identify that we have the hydroxy group here, or the alcohol group here, right, then we know that it has to end in -ol. Okay, that's a suffix for alcohols. And we also know that we have this other branch coming off here. So what is this? First of all, what is this branch? Okay, it has 1 carbon, so the suffix is going to be meth, and because it's a substituent branch, so it's not part of the main chain, the suffix is -il. So it is methyl. Okay, so we know we have to have methyl, we have to indicate the position of that methyl group somewhere in the name, which is what we've done here. And we also have to indicate the position of that alcohol functional group, right, which is right here. So the alcohol is on the 3rd carbon, and that methyl group is on the 4th carbon. So that's what we've done there. Okay? Alright, hopefully that makes sense. And the more you practice these questions, the more fluent you'll get with naming them, and it'll come a bit more naturally. Okay, so start off with maybe go through some more simpler examples and then work your way up to stuff like this here. Okay, because this really does test your understanding of organic molecules. Alright, but if this makes sense, then you're doing great. Okay, alright, cool, thanks, have a good one.